Support for single forest and multi-forest topologies. This is a pretty information-packed lesson, so if you don't understand how the Azure AD Connect tool works, this is going to be really good, and hopefully it'll all start to make sense after this. But first, a quick recap on what domains and forests are in Active Directory. Domains by themselves are logical groupings of network objects, including users, groups, contacts, and computers. And each domain has a repository or database of these objects and has specialized servers called domain controllers that maintain copies of these databases and handles authentication as well as performing many other functions. And there are domain-wide policies that can be implemented, such as access restriction, logon scripts, and password complexity requirements, for example, that can be set for the entire domain. Although now you can do fine-grained password policies, so some of these that used to be only set at the domain level can be set at the user level or the group level as well. Now, each domain has one and more administrator account that has total control over all the objects, policies, and configurations in the domain. It's possible to create additional domains which would by definition have their own object database and domain controllers, but would inherit the same schema and have automatic parent-child trust relationships established called transitive trusts. And if we made these domains what we call child or subdomains, they would have the same domain ending as the parent or root domain, but they'd be preceded by a new identifying word. And sometimes these names are based on the location that the domain is in or the department that the objects are related to. Now, these child or subdomains can have additional child or subdomains themselves, which would again require a new name to precede it. So if the root domain at the top was pfslab.com, the child domain would be sales.pfslab.com, and the next level child domain would be newyork.sales.pfslab.com. And as long as they share the same root domain ending, they're said to be in the same tree. It's possible, however, to have additional domains that do not share the same namespace and are named completely different, but still share the same schema, the same global catalogs, and could also have transitive trust established. And these domains would be part of their own tree, but they're said to be within the same forest. Now, if you needed to have an object database with a different schema, you'd have to create a domain that was not in the same forest as these. And you could still set up trust relationships between this forest and the other forest, but now it's considered to be an external trust. And you often see this as a result of mergers and acquisitions, where it's easier to set up external trust relationships than it is to merge schemas and migrate objects from the acquired domain and forest into a domain in the existing forest. Nowadays, best practice is to create as few domains as possible, with one being the most effective. Long ago, it was considered best practice to create multiple domains due to certain domain-wide policy restrictions, or to better control replication between the domain controllers in different locations, or because there were special administrative boundaries that needed to be maintained. These days, policies can be customized to account for different requirements within the domain, and Active Directory sites can be used to control replication across geographic locations, and a combination of granular permissions and OUs can be used to set boundaries and filter objects for different users. Outside of political reasons or international compliance requirements, there are few circumstances today that call for the creation of multiple domains, but every situation is different, so it's best not to think of this as kind of a blanket thing. Still, you want as few domains as possible. Okay, so when we talk about supporting multiple forests and domains with Azure AD Connect, there's really only two rules that we need to keep in mind. Rule number one, you can only have one Azure AD Connect installation connected to one Azure AD tenant. This means you can't have multiple sync servers writing to the same tenant, and you can't have one sync server that writes to multiple tenants. Rule number two is that you can't sync the same user to multiple Azure AD tenants. And this makes sense since users are uniquely identified by their UPNs. How would this even work? The domain used for the UPN address has to be exclusive to that tenant, and it has to be verified by Office 365. You can't have a domain that's verified by two different Office 365 or Azure tenants, so it makes sense that there can't be two users with the same user principal name anywhere across all of Azure Active Directory. If you have two users that have different UPNs, then by definition they're different users. So on the right-hand side is a legend or key for the symbols that we're going to encounter for the rest of the slides. Although we used a triangle for domains in the previous slide, The official Microsoft diagrams for this topic uses a triangle to represent a forest. And there's no question about the ability to support multiple domains within a forest, so we don't even have to drill down to the actual domain level. We're only going to be talking about forests going forward. If there's a box drawn on the forest, it's meant to represent a filtered forest, meaning a forest where only certain users, contacts, and groups have been selected to be synchronized. And the box with two arrows represents a sync server, meaning an Azure AD Connect installation. The purple one with the dotted lines is a sync server in staging mode, which we'll get to at the end of the lesson. The two-way arrows without a box represents GalSync, which is a tool that's used to synchronize global address lists between forests. And what it does is, it creates external contacts in each of the forests to represent the users from the other forests, so that each forest has a complete multi-forest global address list, including users from that forest and external contacts from all the others. So in this scenario, there should only be one user account for an individual, but there could exist one or more contacts for that person elsewhere. And we'll need a way to merge all of these identities into one object when we import. The box with the lines represents a zoomed-in version of the sync server, which we'll explain in detail on the next slide. And the cloud with the Active Directory symbol represents an Azure AD tenant, which for our purposes is the same as an Office 365 tenant. So to really understand why some topologies work and some don't, we might as well dive into the architecture of the sync server itself, and we'll need to do it at some point anyway. The sync server data storage is split into three broad categories: the incoming connector space, the metaverse, and the outgoing connector space. The incoming connector space is where the data is stored after being imported from an external source, and we're generally talking about Active Directory. We need to create a connector for each connected data source, or CD. The connector is configured with the location and user account to read from an Active Directory forest, and if we have multiple forests, then we need to set up multiple connectors. When the import happens, the data lands in a place called a connector space, and there's one for each connector. So if we have two forests that we're reading from, then we need two connector spaces on the incoming side. These connector spaces really represent databases, and the connector spaces on the incoming side are only used for import purposes and can be overwritten at any time with a full import, and there'd be no negative impact. The connector is configured to import all objects from all domains by default, but we can configure it to only import certain objects if we set up filtering, as we mentioned in the previous lesson. So once imported, the data from the connector space or spaces has to then be merged into the metaverse, which represents the persistent database on the sync server. And this is a locally stored database that's not overwritten, but can be updated with new information or new objects from an incoming connector space. The process of updating data between a connector space and the metaverse is called synchronization within the server. And it's noteworthy here that all the functions, including the two that we've discussed so far, import and synchronization, can be done as either full or delta. Generally, the first process is performed as full, and the subsequent are all deltas, or only changes since the last sync is processed. At some point by now, the sync server has also initiated an import of the Azure AD tenant into the other connector space on the right-hand side. Even though this is the outgoing side, it still performs an import so that it can update the information locally before sending it back to Azure. Now, another synchronization is performed, only this time it's the metaverse updating that outgoing connector space with new information and new objects. And then finally, that updated data in this connector space is then exported back to Azure AD. In both cases, when data is going in or out of the metaverse, it's called a synchronization. When data is coming in or out of a connector space from external sources, it's called an import or an export. When data is being moved through the metaverse, there are different rules that can be applied, and aptly these rules are called incoming sync rules, or ISR, or outgoing sync rules, or OSR. And it's important to remember that these rules are being processed on synchronization actions in and out of the metaverse, not on imports and exports in and out of the connector spaces. With these rules, we can control what objects are updated and with what information. It's almost like writing SQL queries, as we'll see in a future lesson, although Microsoft doesn't call them queries, they call them declarative provisioning for whatever reason. And this is where the group and attribute filtering occurs. The domain and OU filtering happens during the import and doesn't even make it into the connector space. Now, as mentioned, if there's more than one AD forest, then there's more than one connector configured on the incoming side. and each connector can run independent imports into separate incoming connector spaces. At this point, we run the potential for duplicate objects between the forests because there are cases where the same user may be represented in each of the connected directories, or a user and multiple contacts could both flow into these connector spaces. Now, these duplicate identities can exist in separate connector spaces, no problem, but it's important that we're able to combine these identities into one user object when we update the metaverse, so we don't wind up with multiple user accounts in the Office 365 tenant. And we'll spend some time in the subjective going over solutions to this problem. Okay, so now that we understand all that, we can get into the actual supported and non-supported topologies. And what you'll see is that if you understand how the tool works and remember the rules, it's going to be very easy to identify which topologies are okay and which are not. So the first one we deal with is a single forest, single tenant topology, meaning a single forest is in the on-prem environment and a single tenant in the Azure AD or Office 365 environment. And by the way, I'm just going to use Azure AD going forward, but remember, for our purposes, Azure AD tenants and Office 365 tenants are the same thing. So with the first diagram, we see the simplest and most preferred topology. One forest imports into one sync server and exports into one tenant. And this is, of course, a supported scenario because it's the simplest model and it meets both of our rule requirements. The second diagram still represents one forest and one tenant, but now we have multiple sync servers. From the boxes on the forest, we can see that we're attempting to filter the users or objects so that some go to one sync server, others to another, and then the rest to the third. And this by itself is not a problem, but now all sync servers want to write to the same Azure AD tenant. And as we've discussed, this is a no-no. There must be a one-to-one relationship between sync server and tenant. So this violates the rule that you can't have multiple sync servers writing to the same tenant. And these diagrams we're looking at multi-forest environments, but still with a single tenant. So we know from the one server, one tenant rule that if there's one tenant and these are supported scenarios, then we must also be talking about one server in these diagrams, which there is. We've switched to a detailed version of the server, however, because now we need to see the separate connector spaces for each of the forests on the incoming side. In the first diagram, we see users coming into the separate connector spaces and staying separate into the metaverse and remaining separate all the way into the tenant. And this is meant to represent that they're unique users across the forests with no duplication, and this will work no problem. In the second diagram, we see two forests with a trust relationship established. In this situation, a user could be represented as both a user in one forest and also a contact in the other forest. Here we need to find a way to identify that these objects represent the same person before we sync to the metaverse, and we could do this by picking an attribute to match on, which we'll see later. In the third diagram, we have something called an account resource forest topology, and this occurs when companies set up all their users in one forest and all their resources in another, and generally the users exist in both forests, but the accounts are disabled in the resource forests. And there's a type of linking done so that the active account in Forest A can access the resources attached in the disabled count in Forest R. This is most common with Exchange, where an entire forest can be dedicated just for Exchange with disabled user accounts. The active user in the account forest is delegated access and control over the disabled user in the resource or Exchange forest. And when this happens, it's called linked mailboxes. Azure AD Connect supports this because we can again match the enabled account in one forest with the disabled account in another forest and combine them when we run an inbound sync rule while updating the metaverse. And we'll talk about this more in a future lesson. A multi-forest topology that doesn't work, however, is trying to use a different sync server for each forest and then each server writing to the same tenant. Since Azure AD Connect can support multiple forests, multiple sync servers in this scenario is not even necessary. Now we'll look at having a single forest but wanting to write to multiple tenants. Right away we know that multiple tenants will require multiple sync servers, so the diagrams don't even waste time trying to represent a single sync server because we know that we have to work with the one-to-one rule. In the first scenario, the forest is split into 3 sync servers with filtering, and it's assumed that there's no overlap in the filters and that some users will be sent to sync server 1 while others to sync server 2 and so on. Then each sync server having unique users will write to a separate Azure AD tenant, and this works because it satisfies both rules. Each tenant has a sync server, and none of the users are going to be duplicated across any of the tenants. In the second scenario, the same forest is imported into all 3 sync servers with no filtering. Now, this must mean that the same user will wind up being duplicated across sync servers and end up in all 3 tenants, and this won't work because we can't duplicate users across tenants. This scenario should be easy to spot why it's not supported. It actually breaks both rules. You have one sync server writing to 3 different tenants, and it's writing the same users to each because there's no filtering. Now we get into multi-forest, multi-tenant scenarios, but the rules still hold true. In the top diagram, we have completely separate paths. Users in each forest will be imported into a separate sync server and written to separate tenants. Well, what if there's duplicate users, you say? Well, if they are, then they probably have different UPNs since they're in different forests and they'll flow to different users in Azure. But there's not much we can do about this. At no point do the 2 user accounts ever exist in the same database, and they'll just have to be considered separate users with separate unique UPNs. In the bottom diagram, it's very similar to a previous diagram where a user in one forest could exist as a contact in another for the purposes of global address lists. Here it's the GalSync program that's used to automate this and keep this up to date. In this situation, each forest is destined for a different tenant and flows through a different sync server. This is also an okay scenario because although you can't have duplicate users across multiple tenants, you can have the same person have one or more contacts. So there'd be one user across all tenants, but there could also be multiple contacts in each of the tenants for the same person. And contacts don't have UPNs, so there'd be no duplication of UPNs. Here are the last 2 scenarios, and they both involve a process referred to as a sync server writeback. It's where a connector space that is used for import is then configured to also export. And that way you can use the sync server to import from one tenant and write to another, as in the first diagram, or in the second diagram where a sync server reads from one AD forest and then writes that data down to another. The sync server is not supported to operate in this way, and in the first case, it violates the one server, one tenant rule anyway. The last slide here is to discuss staging server mode, and I put this here because it kind of looks like it's violating the one-to-one rule. After all, we have 2 sync servers connected to the same Azure AD tenant. A staging server, however, is not engaged in active writing. It can perform imports and update the metaverse so that it has the same persistent user information as the main server, but it's used as a standby or for testing. As long as it's in staging mode, it doesn't run the risk of overwriting any data to either the source or destination CD, remember that's connected data source, representing both the on-premise Active Directory and the Azure Active Directory. It can have an identical configuration and identical sync rules as the active server and be taken out of staging mode in the event of an active server failure, or you could try out new filtering and sync rules on it to see how it affects the metaverse objects or the outgoing connector space, and then apply those changes to the active server. Either way, since it doesn't perform any write actions to the CDs, in particular Azure AD, it doesn't need to worry about the one-to-one rule. Okay, there's no demo for this lesson. It was mostly just theoretical, and we won't have a demo for the next few lessons, but we're going to have plenty at the end of the objective. Next up, exam review, objective 4.1.